So we're going to do section 4.2 today on exponential functions. We will eventually learn a brand new parent function, but for right now, let's just review some Algebra 1 concepts, mainly the laws of exponents that you've done before. The main one I want to focus on right now is this one right here. Notice it says the cube root of x squared. Notice where the cube root goes. So the root goes at the bottom. So sort of think about a tree. You got your tree here. Your roots go at the bottom. So we want the root, or the index as it's called, to go at the bottom of my equation, and then the squared goes at the top. So now let's talk about exponential functions. So exponential functions means you're going to have the exponent has your variable in it, okay? So we have things like 4 to the x power, negative 2 to the x power, but there are a few problems that you will run into. One of those is that that number right here, where the 1 is and the negative 2, the 4 is, that base, it cannot be 1. So let's see why it can't be 1. Let's just look at this one. F of x is 1 to the x power. When I plug in my x's, 1, 2, 3, 4, 5, 1 to the 5th power is the same thing as 1 to the 200th power. So basically, we have a line that just goes straight, okay, at 1. So that is a problem. It is not an exponential function. It does not go up like exponential functions do. Let's also look at when the base is less than 0. So it has to be greater than 0. Let's talk about why. So if I let this a be negative 2, notice what happens to my y values. Notice that it's at negative 2, then it's at negative 2, then it's at positive 4 and negative 8 and positive 16, and it just does this. That is a problem. That is not indicative of what exponential functions do. Okay, so first thing we're going to do is something pretty easy. We're just going to evaluate exponential functions. So we just plug and chug. So the first one is we have 4 to the x power. And now I just want to know what we get when I plug that 5 into the x. So I get 4 to the 5th, and that's going to be 1024. And we can do that using just a reminder. All you need to do is put 4 and then use your little caret button. Excuse me, let's get out of that. There we go. So I use 4 and the little caret button, 4 to the 5th, and hit enter. That's how you get it. So let's talk about when we have a fraction. So here we have, we should have 4 to the 3/2. Now notice that the 2 is on the bottom. So that would be the square root of 4 to the 3rd. Now, it's just easier to actually do the square root of 4 because we know the square root of 4 is just 2. So you can do it in any order, okay? So I'm going to do the square root of 4 first. So square root of 4 is 2. Raise it to the 3rd power, and I get 8. I don't have to plug this in my calculator, okay? But one where they give you a decimal, that we just plug into the calculator, 4 to the 2.5. So we would plug it in just like we would, just like we did that 4 to the 5th. Anyway, we get 18 point something something, and notice that it says to round to the nearest thousandths. So there's tens, hundreds, thousandths. So I'm going to look at this guy, the 1, and it's small. So I'm not going to do any kind of rounding up. So I just get 18.379 on my lab. Really pay attention to what they ask you to round it to. Here is another one that you should be able to do without a calculator. 4 to the minus 2. I didn't mention this at the beginning of the video, but remember, whenever you have a negative, that just means it goes on the bottom. Or if it was negative on the bottom, it goes on the top. I call that the homesick rule. Wherever it is, you've got to take it home. If it's on the bottom, take it on the top. If it's on the top, take it on the bottom. So I'm going to take that onto the bottom. So that's going to be 1 over 4 to the 2nd. And 4 to the 2nd is 16. So it'd just be 1 over 16. If you plug it into your calculator and you get a decimal, I'm not expecting a decimal for this answer, okay? I would be wanting 1 over 16 because it is easily done without a calculator. Okay, so now let's talk about our new parent function. It is called an exponential function, and it looks like this. Now, it's different than any of the others that we've done because I've got 2 letters in there. Notice it says a to the x. So my x is my letter, is my variable, but the a is the base. It's called the base. So we actually have a whole bunch of parent functions, you could say. All of those functions are going to look the same. It's just one's gonna go up faster than the other one, but they're all. It's sort of it's an umbrella kind of um, parent function. So note that a can be any positive number, but not 1. That's what we were talking about. So it's any equation that is under the umbrella is the parent function. So let's look at this one, 2 to the x power. So first thing we're going to do, I'm just going to plug in 2 points, -1, 0, and 1. So when I plug that in, when I plug in -1, 2 to the -1, we just talked about that. We're going to stick it on the bottom. So it's a half. So at -1, I'm going to be at a half. And then the next one, going to plug in is 2, is 0, and 2 to the 0 is just going to be 1 because anything to the 0 power is 1. That's one of the other rules that we had up there. And then 2 to the first is just going to be 2. So it's going to be right there. Okay, so we've plotted those points. Notice these 3 points are always going to be on your parent function. So 0, 1 will always be there. 0, 1, always on there, no matter which one you do, okay? 1 and the base, and by base, I'm talking about this number. So 1 base, so since my base was 2, I'm going to be at that point. 1, 2. And then -1, and 1 over your base. That's how I got my 1/2. Now, one thing that this one has is it's going to have a horizontal asymptote. Okay, has a horizontal asymptote. So that means this guy is going to go up really fast. But when it comes down, if you don't do the horizontal asymptote, you might continue it like this. Okay, but that is not correct. It has a horizontal asymptote at the x-axis. So it should not cross the x-axis. It should look like that. Okay. So let's look at the domain. So let's talk about what x cannot be. This x can be anything. So my domain is everything. Now my range, notice I don't have anything down here. So I could cut that whole thing off. So my range is going to be from 0 to infinity. Notice my 0 has a parentheses. And that's because there is an asymptote there, right? And then the y-intercept is 0, 1. The horizontal asymptote, we've had these in when we did rationals. So that's going to be y equals 0. Okay, so now let's graph one that's a little bit different than the parent function. Notice this time it has 1/4 to the x power. Now remember, we could write this, excuse me, there we go. I don't know why it is not doing that. Anyway, if I have a to the -2, it would just be 1 over a squared. So I could, just like if it's on the top and it's negative, I'm going to put it down below. Well, now it's, I want to change this fraction to a regular number, so I'm going to flip it. So that's like 4 over 1 to the minus x. You can think of that as 4 to the -1 raised to the x power. So I can make it homesick is essentially what I'm saying. So now we could have an x that is negative. So if I have an x that is negative, or I have a fraction, so I've got either a fraction here, or I have a negative exponent. Let's see what my graph's going to be looking like. All right, so the first thing I'm going to do is just start putting in points. So I plugged in -1. Now this one's, I plugged it into this one, this equation, 4 to the minus x. That way my two negatives just cancel out. It just made it easier. Let's see what else we did. Now we're going to plug in 0. Anything to the 0 power is always 1. And then 1/4 to the 1 power to the first power is just 1/4. So now let's graph those. So I've got -1, 4, 0, 1, which is always the case, and 1, 1/4. And notice it is the same thing that we had before. We have 0, 1 is always there. 1 and base is always there. My base was 1/4, so that's where I got that one. And then -1 and the reciprocal. So I just flipped my base, which was 1/4, just flipped it, so I got 4. Once again, I'm going to have a horizontal asymptote on the x-axis. So this one is going to look like this. So it is going to be a decreasing. So above, when the a value, when your base is positive, it's going to be increasing. And when your a value is a fraction, less than 1, or your exponent is negative, it's going to be a decreasing function. So let's just say it in a geek way. Okay, so if a is greater than 1, we know it can't be 1. If it's greater than 1, like 2 to the x, then it's an increasing function. If the base, the base is a fraction less than 1, it is going to be decreasing. The x-axis is the horizontal asymptote. We talked about that. And then your domain is -infinity to infinity, and your range is from 0 to forever. And these are the 3 big points that will always be on these exponential graphs. So these are the ones that you need to memorize. Okay, -1 and the reciprocal of the base, 0, 1, and 1 base. So let's just graph a couple. So we have 1/2 to the x power. So we have our 3 points, right? We've got to the -1 and the reciprocal of my base, which would be 2, because here's my base. I sort of worked it out longhand, but you could just flip it. 0, 1, and 1 and your base. So now we're going to plot those points. -1, 2, 0, 1, 1, 1/2. Remember, we always have an asymptote here, so we're never going to cross it. So let's graph it. Notice it is decreasing. Again, my domain is everything, and my range is from 0 to infinity. So now we are going to do the same thing that we did in chapter 2, where we moved it left, right, up and down, flipped it, and stretched it, all that stuff. It applies to our exponentials. So let's look at this guy. We're going to be graphing, excuse me, let me do that again. This one, -3 to the x. And as you can tell, that negative is a trap. This is different than, that's not equal to -3 raised to the x power. Remember, we cannot have a base that is negative. So instead, we are going to graph just that guy. And then what does the negative do? Do you remember? It flips it over the x-axis. So first thing we're going to do is we're going to graph just our basic 3 to the x power. And we graph that by having -1, and then take your a value, which was 3, right? And then you just do the reciprocal. You just flip it. So I'll have -1 and a third. So somewhere around there. That is weird. That should say 0 and 1, not 0 and 0. So 0, 1, and then 1, and my base was 3. Now, I'm not going to actually connect those because that is not what we're actually graphing, right? We're graphing the negative of that. I'm still going to have my horizontal asymptote, right? But this time, those points are going to flip over that horizontal asymptote. So instead of being a positive a third, you could think I'm going to put a negative in front of all those. So you can think of that in your mind, or you can write it down, but I'm actually going to do it on my graph. 1, -3. So when I connect it, it's going downhill rather than uphill. All right, now we're going to graph the same 3 dots, okay? Let's go ahead and graph those same 3 dots because we still have 3 to some power. So, -1 and a third, 0 and, I don't know why I put that, 0 and 1, and then 1 and 3. But we're not going to connect those because we're not done. We have this part. What does my x to the -2, what does that -2 do to it? Yeah, it moves it to the right 2 places. So I'm going to take those and I'm just going to move each point 2 places to the right. Even that little weird 1/3. All right. Notice that I did not change my asymptote, right? Still not going to cross that. Then I just connect those dots. Go. So we just moved it to the right. Oh, I forgot to do domain and range. Notice that the domain for both of these is going to be the same. The domain is everything, right? But on the one on the left, this one, notice that I'm taking out this part of the graph paper, right? So it's going to be from -infinity to 0. Oops, excuse me. And then on this side, I don't need the bottom part. So that's going to be from 0 to -infinity. That's it. All right. One last one. Let's talk about what is going to happen on this graph. Okay. Let's talk. I still have my 3 to the x, but I have x to the -2, and then I have this +2 on the outside. So what does the -2 up top do? Remember, that's just going to move it to 2 to the right, and then the +2 is going to move it up 2. So I'm still going to start by graphing my 3 points, -1 and the reciprocal, flip the base, so flip my 3, my 0 and 1, my 1 and my base was 3. I'm not going to do anything to that, right? Not going to connect those dots, but I'm going to take each one of those and I'm going to move it to the right 2 and up 2, right 2 and up 2, right 2 and up 2, and I'm going to connect my dots. Right 2, up 2, right 2, up 2, right 2, up 2. That's about right there. Now notice that my asymptote, which was here, okay, I'm going to take that and it has to go up 2 places, right? I'm going to move that up 2 places. I'll just connect my dots. So everything that we learned in chapter 2 is going to apply in this chapter as well. Okay. Let's see. No. So the domain is still going to be everything, but notice that my range, I'm going to get rid of everything down here. So it's -infinity all the way up to, it looks like 2, right? -infinity to 2. All right, so let's look at the reflection. Translations and reflections of exponential functions are the same as for other basic functions. In other words, we're going to move them right and left and up and down. So to translate them horizontally, the exponent has to have this number, the plus c or minus c in it. So this is what moves it right and left, and then the plus k, we call them k's. This on the outside is what moves it either up or down. All right, so we're going to leave graphing for a little bit and talk about how to solve problems that have x's in the exponent. That is what exponential equations are, right? It's where the x isn't down on the ground. When it's down on the ground, we can do all kinds of algebra to it. But when it's up there flying, there's nothing we can do to it. So we need to get the bases the same. That is the key. Okay, anytime you see an X flying, that's going to be the first thing you try. So I need to get the bases the same. Notice that that this is 5 to some power. So I want to see if I can write 125 as 5 to some power, which I can. So maybe it'll show. Yeah. So 5. So I'll leave this side the same, 5 to the X. And then on the other side, I'll change the 125 to 5 to the third. Now, notice that this 5 is on the ground floor, whereas this one is underneath, right? So we need to pull this 5 up to the top so that my bases will be the same. They're not the same because this one's on the bottom. So remember we talked about how I can make this thing homesick? Okay, and we do that by changing this 3 to a negative. So that's going to be 5 to the negative 3. And once your bases are the same, essentially, you're not really doing this, but essentially, those cancel, they fall down. If you've ever played the video game Tetris, that's what I think of. Once it gets the same and we've got everything the same on the bottom, then that just disappears. And these guys just come down and make a new equation. X equals negative 3. Okay, so let's look at this next one. Okay, the next one, again, my goal is to get the bases the same. So this one has 3 to some power, x plus 1. This one is 9. Can I change either 9 into a 3 or 3 into a 9? I can. I can change this 9. That 9 is 3 squared. So that's what we're going to do. We're going to leave the left-hand side the same. And then my 9 becomes 3 squared. And notice I have the parentheses. So then I have times x minus 1, or raised to the x minus 1 power. So remember, another rule was when you have these two exponents, I call this the peep and tom. Peep and tom is looking in here. You're going to just take those exponents and multiply them together. So this side, the left side stays the same. And then I just combine these by, I'm going to eventually use the distributive property, but notice that my bases are now the same. So those just go away. So we now have a basic equation. We took the x plus 1, that exponent, and the 2 times x minus 3, and now we just have an algebra 1 equation. So we're just going to go through and distribute. And then next is I'm going to subtract my x. You could subtract 2x if you want. It really doesn't matter which side you put it on. So I'm going to get 1 equals x minus 6. Then you just add 6 to both sides. So your answer is going to be x equals 7. All right. So when we describe the process for solving equations, when the variable is in the exponent, what did we do when this variable was up here? Right, we're going to get our bases the same. That's the key. It's what we're always going to try first. Okay, but we might have a problem. You can tell by that face over there. All right, so I could write 16 as 4 squared. I can write my 9 as 3 squared, but notice that my 4 and my 3 are not the same. Now, I actually could write 16 as, I could also write that as 2 to the 4th, but that still doesn't help me because 9 can only be written as 3 squared. So this is just to show you that we can't always solve it by getting the bases the same. We're going to need another method. I'm not going to show you that method today. I know you're going to wait with bated breath to learn how to do it. Anyway, but you're just going to have to wait. You'll have to come to class. So, all right, example number 6, we're going to solve an equation with a fractional exponent. Now, this one doesn't exactly fit in this section, but it doesn't really fit in any section. This is just sort of a weird problem. So now my base is actually, sorry. Oh, hello. Something's going on. Let me pause this video, unfortunately, until my Wi-Fi does something, fixes it.